All right, I'd like to get started with 9.3. This begins on page 246 in your textbook. No fancy starts to this or anything. Let's just get through it because your exam is this week. So this is about where water is found and how water resources are used. And take a look at the pie chart here for a minute and be amazed. It's surprising to see the fact that the public, this is called municipal water usage, is only about 10% of the water that gets used here in the United States. So every time you hear us talk about, the aquifers are being emptied here in Florida and because there's too many people living in certain areas, etc., etc., all of those efforts that we make to try to decrease this 10% are admirable. We already have laws in place. For instance, you're not allowed to run your sprinklers except for 2 days a week, depending on what side of the street you live on. I don't think anybody's ever been arrested for watering their lawn too much. But we have a lot of efforts in place to control what the public uses. We'll talk about some of the conservation methods that are used for this 10%. Just recognize something, and that is if we really want to make a difference in the water usage here in the United States, we need to go after the big ticket items. Agriculture. We're going to discuss that right here in this video, how water is really wasted when it comes to farming. When we talk about power, all of those coal-burning power plants, remember how that works. Do you remember how it works? We boil the water to make the steam, and we boil the water in a coal-burning power plant by burning the coal. 38% of our water gets used at power plants. Now that water doesn't just go away, it gets to be reused. You'll always notice that power plants are near bodies of water because they require so much water in order to make your electricity. Don't forget industry. There's a whole lot of, in fact, if you just think about it for a minute, the manufacture of anything that we make, any big machines that manufacture leather, I don't know, just think of anything that's in your daily life, metal, takes great amounts of water, and yet industry here in the United States only accounts for about 11% of our usage. Our big ticket items are agriculture and power plants, and yet we really won't emphasize that so much. You'll see us emphasize the public use of water more than just about anything else. I'm belaboring a point. I just want you to understand that when we talk about water usage and we try to be more conservative with our water usage, whether you do it at home or I do it at home, it's still a small percentage of the overall water usage. These are our big ticket items. All right, enough said on that. Let's talk about agriculture since it's the big one. Now these statistics are worldwide. This isn't United States, this is worldwide. So for the US, 41% of our water is used for agriculture. But worldwide, it's almost 70% of the water is used for agriculture. And unfortunately, the way we operate with agriculture, most of the water doesn't even reach the crops. In fact, 60 to 80% doesn't. And here's a picture of one very inefficient way to get water to the crops. Remember, no water that lands on top of a plant is going to end up inside the plant. The only way that water enters a plant is up through the roots. So this water has got to get onto the ground. But this is an easy way to get water to your crops. But it's certainly not an efficient way to get water to your crops. In fact, this is the solution. Drip irrigation. There's pictures of it in your textbook, and I'll get to them here in a minute. Not just watering crops so that they will grow during the growing season. But take a look at this statistic. It takes 800 gallons of water over the course of the life of the cow to grow, or for you to be able to go buy 1 pound of grain-fed beef. 1 pound. That's an awful lot of water taken up in order for you to have a steak or a quarter pounder with cheese or tacos. Worldwide, 23% is used for industry. You might remember our statistic was 11%, but worldwide it's 23%, and only 8% is used for what we call municipal use. That's us. So worldwide it's less than here in America. That probably shouldn't surprise you, since we have more water per person than just about any country. In fact, I think there's a graph to show that in a minute. Look at how much water it takes to make a car, how much water it takes to make a pound of aluminum. You can see that just about anything that you can name that's manufactured uses up a great deal of water. This map is in your book, and it's showing you water availability around the world. The darkest blue are the places that really have tons of water. And this is per person. This is already per capita, so it's been adjusted for the number of people. It wouldn't surprise you about these red areas. These are desert areas. They do not have a lot of water supply. They have to worry about ways to get water to their country. Orange and yellow are pretty bad too, and you can see China has a water availability problem per person. Remember, this is not yellow because of all the people in China. This already is accounted for per person. But it's just the fact that they don't have a lot of water resources available to them. India is very bad off. Pakistan, these countries here in this region don't have a lot of water. They don't have a lot of people, but they don't have a lot of water either. And then let's take a look at the bluer areas. We'll cover this in a minute, but by far the #1 country for water availability is Canada. Can you think why? Remember back to video 9.1 in the very beginning, and we saw how much of our available fresh water was tied up in icebergs? Well, guess who owns the icebergs? They're all up here. They're all Canada. So they don't have a lot of people. That's not the point here. The point here is they have a lot of water per person. We are not doing bad here at 6,000 to 15,000 cubic meters of water per person. Mexico's not doing bad. All of South America, no problems. Russia, no problem. Australia, even though they've got the outback desert here, as a matter of a water availability per person, lots of rivers and lakes, they have plenty of water available. Again, I don't think there's any surprises in this graphic. Just pay particular attention to the Canada point. And here's why. If you wanted to do an analysis, because of all of those icebergs up in Canada, they have 20% of all of the fresh water on Earth. They have less than a half of 1% of the people, and they have 20% of the water. Now let's take a look at China. There's a reason that they were yellow on that map. They've got 20% of the people of the world, but they only have 7% of the fresh water. So our water resources are mismatched. India is the second largest country, and you saw that India was orange on that map. So the countries that have all the people, they don't have a lot of freshwater resources. So if you're running that country, you have to be concerned about how you're going to get water to the people. You know, you can't go get some from Canada unless you plan on doing what one country's done. Saudi Arabia's actually tried to break off a piece of iceberg and tow it back down to their country. Obviously, that didn't work very well. Per capita water usage, and this is per day, 7,000 liters per person per day here in the U.S. And of course, we lead the way. We have that water usage. Remember, this is water usage not just in terms of what happens municipal, but also what happens manufacturing and agriculture. Spain, very high, kind of a surprise. As you can tell, most of these countries are developed countries. They have the infrastructure in place to get water to all of their people. Mexico is considered developing country, but they have a lot of water resources just the same per person, and they use a lot of water per day. And then you can see here as we go down the line. This is total per person for agriculture, industry, and households. Varies a great deal, as you can tell. Let's talk about the agriculture usage. You might recall from a couple slides ago, 69% worldwide. 69% of the water is used by agriculture. And the reason why is because in order to grow crops, they need water. Remember, the basic photosynthesis equation is carbon dioxide plus water. So plants need both of those things. Here are the different irrigation techniques. And the one that is the saving grace, the one that is the solution to irrigation problems, is called drip irrigation. You'll see why when I show you a picture. But basically, instead of wasting water by flooding the farmland or furrowing, you'll see pictures of that, or spraying, rather than do these things, you're just putting water on the ground and hoping it will get to the plant. Drip irrigation is a technique that's used to actually put the water right in the soil, right where the plant roots are. Drip irrigation. And then we'll talk a minute about hydroponics. That's the use of water, no land at all. What's the future for hydroponics? We'll talk about that. Again, here's that picture of spray irrigation. Very inefficient. Most of that water ends up evaporating. It never gets onto the ground, and it never gets into the plant. 60 to 80% does not make it. And by the way, that's a soil issue as well, because when water just sits and then evaporates, some of the water that's in soil also moves up with it into the atmosphere. What we end up with is salt being left behind. So spray irrigation, especially when it is not very efficient, and you can tell from this picture it is not, we end up with salts left behind in the soil. It's called salinization, and we have that salinization occur frequently, especially in the early days before the crop has grown to this size. Here's another picture of spray irrigation. You've seen this. This is our typical technique for getting water to our crops. Very inefficient. We need to find better ways for farmers to get water to their crops. Like perhaps furrow irrigation. Now this is not exactly a great idea. You can see how much extra water ends up in the furrow, but the idea here is you dig trenches, you keep pumping the water into the trenches, and the trenches are close enough to the roots of the plants in order for them to get the water that they need. Think of how much of this water gets wasted, especially by evaporation. The sun beats down and evaporates this water. It's sitting there. It's available for the plants, but an inefficient method. Certainly better than the spray irrigation, though. Some crops, for instance rice, grows well when you flood the area. And again, you talk about evaporation. you have to be constantly adding water if this is your preferred method for growing crops. It's called flood irrigation. And this picture here shows drip irrigation. The water drip, drip, drips. This isn't showing much of a drip, but ordinarily there's less water than that coming out of these holes. And these holes are strategically located along the hose or the pipeline so that the water goes exactly where the plant needs it. You can see here's another. There'll be another little hole in the hose there for drippage. Another hole there. You get the idea. All along, the water only leaks out directly to where the plant is. And the reason this diagram is like this is because they want you to be able to see the water coming out of the hole here. Drip irrigation is considered the environmental solution to irrigation for crops. Here's a picture depicting hydroponics. A lot of research is being done with hydroponic agriculture because people are concerned about not having enough space. And if you're in a country where the soil is poor or a country where the soil is very dry, you can at least control the water that you're using in the growing of crops if you do it in a controlled environment like this. Hydroponics is growing crops, plants, without the use of soil. Instead, you use lots of water, but the water that you're using is infused with all the nutrients that soil has, and therefore it's the nutrients that the plant needs. If we were to go to hydroponics exclusively, oh my goodness, think of the water that would get used. But when you think about how much water is wasted with spray irrigation, maybe it's a good trade-off. Okay, that's agriculture. Let's talk a little bit about industry. Industry is the second largest user of our water, and primarily that is because of power plants. I always get a kick out of news agencies that run stories about air pollution, and they'll show you a picture like this. This is not some nasty chemicals being spewed into the air. This is water vapor. These are called cooling towers, and they need to cool the water that got boiled in order to make the steam that turns a turbine that spins a small ball of wire inside a magnet. So it sits here and cools, and then they can use that water again. That's power plants. And when you think of industry, manufacturing, and you think of the amount of water that gets used, remember that pie chart I showed you a few minutes ago. If you count power plants as industry, and you should, then almost all of the industrial water that gets used by power plants. Households. Municipal water is the third largest user of water worldwide. And these graphs show you, first of all, per capita household water usage. And you can see Australia is the worst, or the biggest user per person of water. Canada second. You know, these are countries that have plenty of water, and obviously they're not working very hard in the household to do any sort of conservation. We are third, and there are a lot of things that we can do about conserving water per person. Here's what we use water for. You might be surprised to know that the number one water user is flushing the toilet. Bathing is number 2. Laundry is 3. Cooking and drinking come down way here at the bottom. We use an awful lot of water every day in our bathrooms. And of course, showers and baths take up a lot of water. The future of water availability is a constant struggle for us here in the United States and around the world. One of the things that a lot of states are doing here in the United States is to mandate using plants that don't require a lot of water. This is called xeriscaping. You can see this picture here. A lot of people that live in the desert Southwest, where obviously there's not the same amount of water available for them, have taken to xeriscaping. They make their yard look very nice. They use plants that don't require a lot of water, drought-tolerant plants that don't require a lot of water. And you can see, rather than try to grow grass, they'll use gravel or something like that for their main part of their yard. Why try to grow grass in places that is not hospitable for the growing of the grass? There's been a great deal of battles over the years about who owns water. We've had that battle right here in Florida. In fact, there's an ongoing lawsuit happening between South Florida and Central Florida, and between Central Florida and North Florida, about access to water resources. But water conservation is the key. And I'd like you to come to class ready to talk about some things that we can do to conserve water in our own homes. You'll know some of them. We even see them exhibited around here. The good news about water availability is we here in the United States are taking efforts to be conservative about our water. And I mean, you can tell that by the fact that we are number 3 in per capita household water use. And I think more and more Americans are concerned with how much water they use. One of the ways to make people concerned, of course, is to pass laws that make it illegal, for instance, to run your sprinklers at certain days. Another thing to make people more aware is to run public service announcements. Let people understand and know what's happening. Or another thing, and it's happened right here in Clay County, is raise the prices of water, and that will get you to think twice about your water usage. Here in our county, we're on a tier system, so the first 2 or 3 tiers, which is water usage, thousands of gallons, is cheaper. And it's only the people that really use a lot of water to get into the 4th tier. That water is way more expensive for them. So it's not a straight cost per gallon for the homeowner. And the idea here is, if you're a real heavy user of water, you're going to pay the normal amount at first, but once you get up to a higher amount of usage, you're going to have to pay more for that water. The idea is to incentivize people to be more conscious in their water usage. Point is, it's paying off. And we can see what was once almost looking like an exponential growth curve when it comes to water usage, water withdrawals worldwide. Things have tapered off. Good news for us. What are some things that we can do? Well, you should read some of those statistics that are in the book on page 251. A typical toilet, for example, from the old days, back before 1994, used 7 gallons of water per flush. 7 gallons. Nowadays, if you buy a toilet that was made after 1994, or if you're like me and you go to Home Depot and purchase a new toilet, they use much less water. In fact, the toilets that are sold today only use 1.6 gallons. And you can do that math. That's like 5 times better. Showers. We're the second big user of water, showers and baths. A 10-minute shower using the standard shower head would use 40 gallons of water. A 10-minute shower, 40 gallons of water. And think about how many times you do a shower that's longer than 10 minutes. So you're using way more than 40 gallons per shower. Nobody's saying don't shower. In fact, we all appreciate it when you do shower. The fact is, we can use shorter showers, or you can purchase these more modern shower heads. The more modern shower heads reduce your water usage 37%. So now, using these reduced flow or low flow shower heads, 25 gallons for a 10-minute shower instead of the 40-gallon. Watering lawns, filling swimming pools, they all add to the water usage. So what can we do about it? Here's something that we do right here on Fleming Island, and that is the use of reclaimed water, also known as gray water. It's known as gray water because it's water that has not been completely cleaned up. You will find neighborhoods and communities that use reclaimed water on a neighborhood basis. You will find that these neighborhoods are the new ones. And that's because they have run pipelines under the streets to the homes, out to golf courses and places like that. They have run water lines specifically designed to hold reclaimed water. Because after all, whatever leaves your house has got to go somewhere. You want the water that leaves your house to get treated. And most of the time you've got one pipe that leaves your house and it goes to have that water treated. Well, we can use reclaimed water. Water that it's not sewage. It's water that's not down your toilet or your drain, like kitchen, because a lot of foodstuffs and nasty things go down your garbage disposal. So reclaimed water is water that comes from showers. It comes from wash machines. Now that water doesn't make the trip all the way to the water treatment facility and get the full treatment. Instead, that water is held. It sits in a settling tank so that the solid materials can fall down to the bottom. And then that water is pumped back to places like this. Places like golf courses. Obviously, golf courses require a great deal of water to keep that grass nice. Everybody likes a nice, beautiful green golf course. So they've taken to using gray water. You'll notice in Fleming Island Plantation, and I think Eagle Harbor has it too, they have signs on all of their water sprinklers. So all of the water that they use for the common areas to keep the grass nice and to keep the plants is reclaimed water. That's water that's not completely clean. And that's why they say do not drink this. It has not been chlorinated. It may have bacteria in it. It could be harmful to you. Reclaimed water is good news. All of our new neighborhoods are required by state law to have pipes put down in place so that we can have reclaimed or gray water. Now it's a lot harder to turn a current neighborhood into a place that uses reclaimed water because they'd have to dig up all of the roads, they'd have to dig up the houses, the pipes under the house. It would be just too impossible to do. But wherever possible now, new neighborhoods are being piped so that they can use reclaimed water. Come to class ready to talk about some of the things you think we can do to do a better job with our water availability. This picture here is a great idea. It's being used, what's it say, in Turkey. A Turkish inventor designed this. It's a wash machine on top of the toilet. I know you think it's nuts, but here's the idea. The water that gets used in the wash machine, instead of just going down the drain, can be reused again. It can be used a second time. The water that was here, because after all, that water's not real nasty. The water that was in the wash machine can also be used to flush the toilet, because after all, you don't drink out of the toilet, do you? You don't need water that's in your toilet to be perfectly clean. The way it is in your house now, it is. The water that's in your toilet is the same water that comes through your faucet. It's all perfectly drinkable. Well, let's try to reuse some of the water from wash machines, let's say, and use that to flush our toilets. All right, I think that's about it. Let's see if there's anything else. No, that is the last slide. We're at the end of the chapter. What's that mean to you? Maybe you might want to look at numbers 1 through 10 on page 154 ahead of time and look up those answers so you get a good grade, because we're going to have a quiz. I don't know why this thing keeps jumping up. And don't show me this message again.